Hello class, good day. Welcome to our lecture number 1 for our subject, Statics of Rigid Bodies. So this is our introductory lecture where we will be talking about the basic terms and the study or the science of statics. So first, let's define. What is mechanics? Basically the relationship among forces and their effects on particular bodies. So, mechanics deals with essentially the study of forces. So, according to Professor Newton, a force is something that can make a body move or make a body moving stop, or an external magnitude, a vector quantity applied to a particular body, and the unit is mass multiplied by the acceleration. Okay, so the unit is basically newtons in honor of Professor Newton. So a much formal definition is a science which describes and predicts the conditions for rest and motion of bodies under action of forces. And finally, a physical science. That's why we are dealing with computational mechanics. We're also dealing with physics. Okay, so we will deal with mass multiplied by acceleration, giving us our forces. So mechanics is actually comprised of the particular branches. So we will talk about rigid bodies. So what does rigid body mean? Meaning it is not deformable, but it is fixed. Once you apply the particular force, the body shrinks or expands. Okay, so for deformable bodies, the body is actually deformed. In a civil engineering example, let's say beams deflect. Okay, your beams are bended, or thus prolonging to bending may cause to failure. And finally, mechanics can also deal with fluids, your air, your water, and any fluid quantity, whether incompressible or compressible. But for our subject, we will only deal with statics of rigid bodies, talking about bodies at rest or bodies moving in constant motion. Okay, constant motion meaning no acceleration. Now, what is a force? Essentially, a force represents a vector quantity, the action of one body on another that tends to change the state or state of motion of body. So as we said, represented by a vector, meaning an arrow and a capital letter, characterized by the point of application, the direction, and the magnitude. The magnitude, the strength of the force, the unit of the force. What is the effects, or what are the effects of forces? So 3 result. Acceleration of the body tends your body to move. Deformation of the body and development of other forces, the law of interaction. Okay? An example of this in a layman's term, when you punch someone in the face, essentially that person will punch you also. Okay? Because you develop a reaction of forces. Okay, a reaction of emotion. The same thing with bodies. When you tend to punch a wall, the wall tends to punch back. The force reacts. Therefore, your arm or your hand will experience pain by the reaction of force. So, for example, let's have this diagram. Once an applied force, we will have this diagram, the development of other forces. Once an applied force, there will be a reaction or develop of internal forces. For this one, this will be talk about in theory of structures when we will talk about stresses. Okay, so just a brief preview or background of this one. The formation of the body, once applied the force, the body has deformed. So it gets long and from tall, gets smaller and smaller. Acceleration of the body tends the body to move to a particular direction from the applied force. So as we said, the properties of forces are the three critical parts or the point of application, its magnitude, how strong it is, and its direction, whether upward, downward, to the right, or to the left. Okay, so for example, in this case, we have a force of magnitude of 10 newtons, a direction of 30 degrees. What is this? 30 degrees northeast. Okay. And for this one is 30 degrees northeast, and this one to the left, no? Toward the west. So 30 degrees W30S. Okay. Some other definitions, particles and rigid bodies. So again, particles are in this case, we will talk about bodies. Let's say we have this doesn't mean the particle of atoms, okay? Not like that, but the particles dealing with the bodies that we will talk about, or the bodies that will receive forces, okay? So for example, we can consider a particular truck, a heavy truck, one particle or one unit particle, wherein it is some force applied to it, friction, the weight, and the reaction of forces carrying its wheels. Okay, so we will talk about rigid bodies in this course. As we said a while ago, that rigid bodies will deal about non-deformable bodies. Okay, for the context of this course, we will not talk about deformable bodies. So it will be talked about for your mechanics of materials. Okay, so quantities involving in statics of rigid bodies, particularly length, mass, time, and the force. So we will deal with SI units only. For length, meters; for mass, kilograms; for time, seconds; and for your force, Newton or kilogram per multiplied to meter per second squared. And some constant to remember, your constant acceleration due to gravity, negative 9.81 meters per second squared, or 32.2 feet per second squared. Okay, so that will be it. I hope you learned something today, and that will be our lecture number 1 for introductory course for our statics of rigid bodies. Thank you.